Ben had 50 more coins than Joan. After Joan had given 29 of her coins to Ben, she had 1/3 as many coins as Ben. And we're asked, how many coins did Ben have at first? Okay, so as usual, we're just going to draw what we're told and see where that gets us. So we've got two people here. We've got Ben. Okay, we're going to draw a bar for him. I'm going to draw a bar for Joan. And what have we got? What we can do, actually, sometimes it's easier to start with the bit that's easier to draw, if that makes sense. So I'm just going to draw the situation at the end where it says, after Joan had given 29 of her coins to Ben, she had 1/3 as many coins as Ben. So let us draw the end situation. And in the end situation, okay, Ben has 3 parts, okay, and Joan has 1. All right. Okay, can we see that? So this is after the giving of some coins. She, which is Joan, so Joan had 1/3 as many coins as Ben. So hopefully you'll agree that that is what this model represents. Joan has 1/3 of what Ben has. But what happened to achieve this? Well, Joan gave 29 of her coins to Ben. So let us draw a sort of extra bit. I'm going to use another colour just to make it clear. So imagine that this part, this bit here, and I don't know how big this should be in relation to the rest of the model. I don't know. But let's say that this is the 29 coins that Joan gave away. And who did she give them to? Well, she gave them to Ben. Yeah. And they are now, and these 29 coins are included in this final thing that I drew. So we're going to draw that in here, 29. Okay. And actually what we should also do is make sure that we mark what is this? So this is the end situation. That's at the end. All right. And this bit here is also the end. Okay. But at the start, so these blue bits at the start, Joan had this additional 29 coins. And at the start, Ben did not have these 29 coins. Okay, hopefully that makes sense. Right. So I think I have captured the situation. Now, what have well, I've captured the situation. I haven't captured all of the information because what we're told is that Ben had 50 more coins than Joan at the beginning. Okay, so let's have a look. Let's look at where the beginning is. So in the beginning, okay, at the start, this is what Ben had. Okay, and at the start, this is what Joan had. Okay, hopefully you are with me. And what we're told is that the difference, so this is the difference, that the difference at the beginning, Ben had 50 more coins than Joan. So where's that going to go? Let's look at the difference then at the beginning. And if we look, that's the end of Ben at the start. That's the end of Joan at the start. So we have a value here going from here to here, okay, is 50. Okay, so how does that help us? Well, we've got this model. We've got these equal parts here. This is equal to this is equal to this. And what we're always trying to do in a bar model is to see if we can give a value to these equal parts. Well, hopefully you can start to see we have got this is actually, let me use another color to emphasize. I don't know if this is going to do it. So obviously this is a part, this is an equal part, this is an equal part, okay? And here we have these equal parts. And hopefully what you can see is that from here to here represents two equal parts, and we have values for all of that. So let's have a look. What can we draw? We can draw that from here to here. We have got 29. Okay, from there we've got 50, and we've got 29. So if we add those all together, all right, so the 29 plus 50 plus 29, okay, that is going to give us 108, and that is the value of two equal parts. Okay, so that's 108 altogether. And if we divide 108, if we divide that by 2, we are going to get the value of each of these parts. So that has a value of 54. 54, it represents 54 coins, 54. Okay, well, I think we've got values for everything now. We can answer the questions, can't we? Let's have a look. We're asked, how many coins did Ben have at first? Okay, so at first, that's this bit here. That's our question. Actually, when I said we had values for everything, we don't have a value for this part, but we can calculate that, can't we? So we know that one part is 54. So if we've got 54, if we take away 29, we are going to end up with 25. Okay, and that is the value of this part here. Okay, so what do we need to know? We need to know we've got 54 and 54 and 25. Okay, so we already know from when we did this calculation here that that is 108. Okay, so we could do 108, and we can then add the 25, and we're going to end up with 133. Okay, you also could have decided to do the 54 times 3 to give the total amount at the end, and subtract, of course, then the 29. Doesn't matter which way around you do it, you're going to end up with the same answer. But hopefully, if this was puzzling you a bit, you can now see how drawing it, I think, makes it clear that you can calculate the value of these two equal parts. And that, of course, then gives you the means to solve the entire problem.